Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, the head of Kainaat Studios, giving science and astronomy to South Asia a la Carl Sagan's Cosmos, the Carl Sagan of Pakistan, Salman Hameed. And today, we usually talk about what's going on with NASA budgets or should we go to Mars or the moon. But since Trump and Musk have definitely gone their separate ways, we are going to talk about a planet and its binary star system that have gone their separate ways. It's sort of like this exoplanet and its binary star system are doing the whole if you could pat your head and rub your belly at the same time in a way that scientists have not seen very frequently before. Do tell.
Right. So I thought, after talking for several weeks about this depressing news about sort of like budget cuts or international students or researchers and what's going on, let's just talk about science. And there was this small story. It was a research paper, but the story was really small. And it caught my eye because I think it's really cool. And so, as we always talk about, whenever we talk about exoplanets, we have to remind people that it was not that long ago, in fact, exactly 30 years ago, that the first exoplanet was discovered around a star like our sun.
Proven. It was theorized for many, many years before that, but we finally got the evidence to say this is a real planet outside of our solar system.
And in fact, we're going to talk about its actual anniversary of the discovery, which will be in October, or the announcement of the first exoplanet. So that will be in October, 30 years ago. And we now have close to 6,000 exoplanets. And that's amazing. Confirmed exoplanets. And so people have started to get an idea of their properties because you have enough statistics to know around what kind of stars that we can detect, what type of orbits do they have, what kind of properties do they have, and some are strange, like, for example, super Earths that are bigger than the Earth but smaller than Neptune, planets that don't exist, their analogs do not exist in our own solar system. And so these are all these interesting things, but you still find fascinating cases that we could not imagine, or they shed light on these things.
Or shouldn't exist given the known science, like how they're behaving is odd for what we know.
Well, but that's what it adds to us. It's like, oh, here is a case. And I should mention that there are also the reason why we know a lot of planets around stars like our sun. It's also this observational thing because we like to look at those stars as well because if we are trying to look for interesting planets, we look for stars that are like our sun.
Yeah, we're trying to find ourselves in another solar system. That's why we're always talking about the Goldilocks zone and Earth-like planets and things like that.
But here is a planetary system. So first of all, it's a binary star system, meaning to say two stars are orbiting each other.
Which, of course, you recognize from the end of Star Wars: A New Hope, when Luke Skywalker puts his foot up and looks at the two setting suns on Tatooine.
That's right. So it's that kind of a system, except it's a little weirder than that, and we'll come back to it in a second. Let me give you the puzzle first. So this system is about 75 light years away. So, relatively close by. And the two stars are orbiting each other relatively close, about 2.5 times the distance between Earth and the sun. So astronomers call that astronomical unit, the distance between Earth and the sun. So this is about 2.5 astronomical units away. So very close. You see, you have another star close to it. And so that was already an interesting star system. But then there is a detection of a planet. Now, that is really strange because it's hard to have planets around binary star systems. For various reasons, they can get ejected but now we know that if there are far enough stars, you can have planets around, for example, one star. You can also have a planet that goes around both of the stars. That's called a circumbinary. You can also have that. So those are stable systems because otherwise you get into a three-body problem.
Yes, which people now know because of the show, and there was a book, I think, too. Yeah.
So you can have planets, but they have to be in a particular configuration to be stable. Otherwise, they will get ejected out. So in this particular star system, as I mentioned, the second star is about 2.5 times the distance between the Earth and the sun. But here's the mystery. But the planet that the astronomers have detected appears to be right in between them, about 1.3 astronomical unit away or close to where the Earth is in that system around this binary star system. So this planet is in between the two stars, and that is very hard to explain. Now, there is another puzzle to that. So one of the stars, both of those stars are actually not stars like our sun. And by what that I mean by that is, astronomers call a star, by definition, in some sense, when in the nucleus, in the center of the star, the energy is being produced when you have fusion, when you are converting hydrogen into helium. That's called a main sequence. You don't have to worry about the name, but that's called a main sequence star. That's the lifetime where a star spends most of its time in. Our sun is a main sequence star, and most of the stars that we talk about are those main sequence stars. But after you have run out of hydrogen at the center, that's going to happen to our sun as well, they start to change, because then you need to have hotter temperatures to, for example, fuse helium into something. Hydrogen you cannot fuse anymore, so you've run out of fuel. So you need to fuse helium into carbon. But before you do those type of things, the star changes, and first it becomes a little bit bigger, and that's called a red giant. And before that, there is a stage called subgiant. But you have moved on, you have run out of hydrogen at the center. Now, one of the stars in here is that subgiant star. So it's no longer a main sequence star, it's a subgiant, it's a little bit bigger, on its way to being a red giant.
It's making its comeback. It was a big, bright star. It's lost some of its glamour, but before its big comeback.
It says last hurrah. But the other star is even stranger, because that star has already gone through this stage, and that star is now a white dwarf. That was going to be the end stage of our sun as well. That is the leftover core that is there when you have shed out your outer material, outer envelopes, and you cannot do anything else than just cool down. That's what it's doing. And so here is a puzzle. What astronomers can detect from simulations is that the two stars were even much closer, about 1 AU apart, and then right now something led them to go a little bit farther away. And that, they think, is when the first star became a white dwarf. Before that, it also went through subgiant, red giant phase, and then shed off its material. And that shedding of the material took it a little bit away because of momentum, and now it's a little bit farther away. Okay, all of this is well and good. We understand that how binary stars evolve. This is evolution of binary stars. So where does the planet come from?
Where does the planet come from?
Well, so there are two puzzles. First of all, that planet, if it existed beforehand, it would have been ejected, because that's where the second star was.
Mm-hmm.
And secondly, and this is what really triggered these questions, the two stars are orbiting in one direction. They're orbiting each other in a particular direction. But the planet is going the opposite way.
So it's like patting your head and rubbing your belly at the same time. It shouldn't be able to happen.
That's right. So what we understand how planets form, we think about sort of like, there was a protoplanetary disk earlier on. That's how our sun formed. And that nebula, that gases, collapsed into a star. But before it collapses into a star, it collapses into a disk as well. And out of that disk, you form planets. And as you can imagine, with the conservation of angular momentum, all of these things are usually moving in the same direction, because it makes sense, because the way the cloud collapses, the way the planets would be, that's the reason why all the planets in our solar system move in the same direction. The sun's rotation is in the same direction. So that totally makes sense.
Yes.
Here you have two stars that are moving in the same direction. Makes sense. They form from the same nebula, and now, even though they are at different stages of life, but they're moving in the same direction. But the planet, which is in between, is moving in the opposite direction. That is very strange. And the reason why that is what astronomers think is happening is because there is no other way to stabilize this planet. So they haven't seen the actual planet's motion going in the opposite direction, but that is the only way simulations suggest that this system can be stable with the planet if the planet is going the opposite.
Because if it were going the same way, it would be ejected.
It would have been ejected.
Be the three-body problem.
That's exactly right. So now it leads to a really fascinating puzzle. how do you have a planet that is going the opposite way because the two stars which are formed together are not going in that direction? And what they think is going on is that when the first star became a red giant, and then after that it started to shed its gases, it's called a stage called planetary nebula, even though it has nothing to do with planets in general. It has nothing to do with planets. It's just you have a core at the center. That's going to happen to our sun as well. And then it shed its gases. Now, and by the way, if you really want great wallpapers for your computer screens or something else, just Google planetary nebulae and Hubble Space Telescope. And you're going to get such beautiful images because we have seen these in many different phases, the way the stars eject gases. They just eject beautifully in that sense.
I love anything that talks about ejecting gases. Whether you're in a small car with your family, whether you're under the covers with the one you love.
I knew I was falling into this, so I tried to get out of it, but it was too late. The words had already gone out.
Let's talk about Uranus. No.
So in this particular case, what simulations tell astronomers how they can explain the system is that when the first star became big and they became this planetary nebula where you have a central core, which eventually would become a white dwarf, they have a central core surrounded by the gases. Those gases were being pulled by the neighboring star.
Mm-hmm.
And as it was being pulled, it formed a disk around the first star, basically. And out of that disk, it created a planet. So this is a very different and unusual way of forming planets because you have material. The process is the same, that you have a material and parts of the disk condenses out and forms into a planet. But the only way we knew before it happens is, for example, in these big nebulae and when the stars are forming.
So in the early phase of a star's life, not in a late phase of a star's life.
So this is the case where a planet has been formed in the late stages. Now,
that's like Janet Jackson. She want to have a baby after 50, I'm for it. If you're a star and you want to have a baby in the late stages, go for it.
And that's why this particular system is not the Janet Jackson.
Oh, yeah, okay. Right.
But right now, why this planetary system is interesting is because it actually tells us that there are other ways of forming planets. Now, I should mention there is one other element which we have no answer to. So if you can form planets when the star is forming, alongside with that, which we know most planets form like that, and you can also form, in some cases, planets like that. Are those planets different? What makes them different? We don't know. That's why this case really interesting. Now, if I can just close the loop. So this is a very interesting system. You have this planet that is going in the opposite direction between the two stars. Most likely it's not habitable. Those stars are already dying, so it's not stable.
That star should have been ejected long ago. I mean, the planet should have been ejected long ago anyway, given what we know about science.
So probably it's a relatively new star system. Nevertheless, it's utterly fascinating. But, and here is something that comes in that we talked about right in the beginning, that the first planet was discovered 30 years ago. And I had a qualifier in there around a star like our sun. The thing is that there was a discovery of another planet, and I think there were two planets around a dead star, around neutron stars, and that was a very weird system. And in fact, after that, we've only discovered a few of those type of systems where there is a star much bigger than our sun that exploded into a supernova and was left with this tiny little core about the size of a city, and that rotates very fast. It gives out pulses. And because of the measurement of the pulses, you can actually be very precisely measure what's going on around it. And astronomers had detected a potential presence of a planet. And there, they also thought that this is not the normal way those planets may have been formed, but instead, when the star exploded, those gases, it may have led to the accretion of material into a planet. So that's a very unusual system. We haven't discovered many of those, but that is another strange one. And now, this particular system called New Octantis, probably this is a fascinating one where you have a binary star system going one way and its newly formed planet going the opposite.
So in this binary star system like on Tatooine, with stars in their dying phase creating new planets, something we didn't think was possible before, this planet is a new hope.
That's right. And just like in Tatooine, the two stars look normal, meaning to say they are main sequence like stars, and we can tell, just like when I told you that one of the stars ended its life earlier than the next one, and next is going through its later phases, we can already tell that the star that has ended its life is a little bit bigger, more massive than the second one. And the same thing we can actually say just looking at the stars in Tatooine. The bigger one probably is more massive than the smaller one, and the bigger one will end its life sooner than the second one. And who knows, there's going to be a new hope in there.
Your dog Wookie, very excited about all this Tatooine talk.
That is exactly right. Wookiee cannot stop talking about Tatooine.